factors affect how fast the solute will dissolve? So I want you to think, if you put sugar in your tea, what factors are going to affect how fast it dissolves? And you should be able to think very quickly what two of them are. And one of them is stirring. Okay, so if you mix, if you mix the solution, if you have an increase in your mixing, then that's going to equal an increase in your rate of dissolution, which is what dissolving. It's another word for dissolving. Another thing you can think about is if you make lemonade versus hot tea, the temperature makes a huge difference in rate of dissolution. So this is how fast something can dissolve. So the higher the temp, the higher the rate of dissolution. Okay, so it will dissolve faster. I think I spelled it correct that time. I was just being really messy. All right, the very last thing you might not think of very easily, and I want you to think about why you grate your salt or your sugar before you put it into your food or your tea. So, and that's because you're making the particles smaller. So particle size makes a huge difference. And another word for this is surface area, or another way we can think about it, a surface area. So as size decreases, that equals an increase in how quickly it will dissolve. So the smaller the piece of salt, the more quickly it dissolves. And I want you to think about why. So I'm just going to draw some small pieces of salt or sugar here, however you want to think about it. And then I'm going to draw one big chunk. Okay. Now, we just talked about why something dissolves, and it's because of the intermolecular forces of that something with the solvent that it is in. Now, if you take a look, the areas where this big chunk of salt or sugar would feel attraction towards, say, water, it only has so much surface area on the outside. Okay, there are only so many water molecules that can come in and start separating it, okay, and dissolving it. Over here, each little circle, I can't zoom in on it anymore, but each little circle, those water molecules can surround every little circle. So because there's an increase in surface area, if you combine all the surface areas of all these little circles or these little bits compared to the larger whole, the water will be able to separate these little bits a lot more quickly than separating the outside here and then the outside again and then the outside again. So as the size decreases, the rate increases. Next up is what factors impact how much solute will be dissolved. So what we just talked about was the rate at which solute dissolves. Now we're talking about amount of solute, okay? Amount of solute dissolving, okay? So in what circumstances are we able to dissolve more? In what circumstances do things dissolve less, okay? So first we're gonna take a look at this temperature diagram. So you can see here, solubility, if you take a look at the axis here at the unit, it says grams per 100 grams of water. So what this means is as you look at these numbers on the y-axis, those numbers represent grams of whatever substance that we're looking at dissolved in 100 grams of water. So that's what this unit means. You are going to see this throughout this unit. So keep that in mind. So this particular diagram is representing majority solid. The x-axis represents temperature. Okay? Temperature does impact how much can be dissolved. So what we see here is at 10 degrees, let's take a look at the red line. That represents NaNO3. So at 10 degrees, about 80 grams of NaNO3 is able to be dissolved in 100 grams of water. Oops, 100 grams of water. Now, if I was to increase that temperature, okay, if we were to increase that temperature to 60 degrees Celsius, take a look. We're able to dissolve more. We can dissolve about 110 grams into 100 grams of water. So as we increased the temperature, you have an increase in the amount that you can dissolve. But I do want you to write down that most solids increase in solubility with increase in temp. We have solids in this diagram. This one is gases. So I want you to think of gases really far apart. Their ability to be dissolved in a liquid. Now, if we increase the temperature, so here's a little fire here. You increase the temperature, maybe we change that into a reddish color. Because why not? All right, we increase the temperature there. Now, what ends up happening is those gas molecules, they speed up. They speed up so fast, they're moving around, zipping around, and eventually they escape the liquid. So it's a little bit different than the previous, where over here for solids, if we increase the temperature, like putting sugar in hot tea versus cold tea, we're able to dissolve more if we increase that temperature. Over here, if we increase the temperature of a liquid where there's gases dissolved, we increase the temperature of that liquid, you see that less is able to be dissolved. And that's because they're moving around so fast that eventually they escape the liquid. Okay? So over here you can say the increase in temp of a gas dissolved in a liquid, you end up having a decrease in solubility, or an amount, okay, of solubility. Again, it's because at high temperatures, those gases that are dissolved in the liquid, at high temperatures, those gases are just going to evaporate out. Okay, they just evaporate out and they no longer are able to be dissolved. All right. The last thing we're going to talk about is how pressure affects solubility. So here, I want you to think of well, actually, I really like this image. We're going to take a look at this image. I want you to think of opening a can of pop, okay? Now, first off, or a bottle of pop, okay? You hear a little tss noise, okay? And eventually, if you were to leave that can of pop open, or if you pour it into a glass and you want to save it for later because, you know, maybe you had to go somewhere and you want to save it for later, you put that can of pop in the fridge, and then maybe a day later you come back to it and you taste it, and all of a sudden it tastes awful. It's just flat. So what ends up happening is when you first hear that sound, that is causing pressure that was applied in order to get that CO2 into, or the carbonation, it's CO2 dissolved into the liquid that it's in order to get that gas in there, those bubbles, it ends up, you have to pressurize that can, okay? And what that does is that the pressure from the outside ends up pushing the gas molecules above it into the liquid, okay? So if you increase the pressure of a gas above a liquid, then you increase the solubility. Okay, if you decrease the pressure, this would be like opening a can of pop. Or if you're from any other state, soda. But we're in Ohio, so pop. But if you open it, that releases the pressure above that solution, and therefore eventually those gas molecules leave the little can of pop, and then it gets flat and it tastes gross. Well, maybe it tastes just the same. It's just we don't enjoy it as much because we don't get those little bubbles on her, that bubble sensation. Okay, but that's what's going on. All right, so let me see if I missed any notes. I think it was just if you increase the pressure, it increases the solubility. So I guess you can write that down. So if we increase P, that increases solubility of gas. Alrighty. And then you can see the little direct and indirect relationships at the bottom of your page there.